Right, okay then Year 12, welcome back. Hopefully you've had a really nice half term in the sunshine and you've had a chance to consolidate your learning, everything that we've done on aerobic respiration so far. So before we get on to the fourth stage, oxidative phosphorylation, I would like you to cast your minds back, okay? I would like you please to pause this video and just take 10 minutes out to write down the different products that are a result of glycolysis, the products that you get at the end of the link reaction, and the products that you get at the end of the Krebs cycle. All right, so pause it for 10 minutes and then come back to me and let's see what you've got. All right then, off you go. Okay everybody, so hopefully for glycolysis, you will have got, for every 1 molecule of glucose, you will have ended up with a net of 2 ATP. Remember, you actually make 4 ATP, don't you? But you needed to use 2 ATP to get the whole process going. So 4 take away 2 is a net of 2 ATP. You would have also made 2 molecules of reduced NAD. All right. Remember, another way of writing reduced NAD is NADH plus H plus, because reduced NAD is NAD carrying hydrogen. And then finally, you also make 2 molecules of pyruvate. So we started off with a 6C, all right, a 6-carbon molecule, glucose. And at the end of that, we've got 2 3-carbon molecules. All right, everyone, so that is what you got in glycolysis. Right, let's have a look at the link reaction. So glycolysis happens in the cytoplasm of the cell. The link reaction happens in the matrix of the mitochondria. So we started off with pyruvate, didn't we? But don't forget, you've got 2 molecules of pyruvate. So in that case, because it's 2 molecules of pyruvate, you're going to have made 2 molecules of CO2, and you're going to have made 2 molecules of reduced NAD. Ooh, 2 times reduced NAD. So this here is the link. All right. And then, of course, at the end, you have got your 2-carbon molecule acetate being carried by the coenzyme A. So coenzyme A, when it's attached to acetate, is called coenzyme acetyl coenzyme A. Sorry, it's been a long half term, hasn't it? My brain's not been working. So 2 times acetyl coenzyme A. All right. So that is the summary of our products from the link reaction. Note that there's no ADP made during the link reaction. All right. Okay, so the last time I saw you, you were looking at good old Krebs cycle. So the 2-carbon acetate is carried into the Krebs cycle by coenzyme A. Coenzyme A drops off, and then it goes back to the link reaction where it can be recycled. And the acetate, the 2-carbon, joins with oxoacetate, which is a 4-carbon molecule, to make a 6-carbon molecule, citrate. And then the citrate goes through several processes where it returns back to a 4-carbon molecule, oxoacetate. So let's have a look at the products that we get from the Krebs cycle. All right, so first of all, 1 whole cycle of the Krebs cycle, we make 1 ATP, don't we? But remember, 2 pyruvate, hence there are 2 molecules of acetyl coenzyme A. So we have to go around the Krebs cycle twice, once for 1 molecule of acetyl coenzyme A, and then again for the next molecule of acetyl coenzyme A. So for the Krebs cycle, a summary of our products are as follows. 2 molecules of ATP. Now you make 2 carbon dioxides for 1 cycle, so therefore it's going to be 4 carbon dioxides because you make 2 on 1 cycle, 2 on the next, and then 6 reduced NAD. That's 3 on 1 cycle, 3 on the next. And then finally, 2 molecules of reduced FAD. All right, these two, remember, are coenzymes, and they're both made from vitamin B. So you get 1 reduced FAD on 1 cycle and another reduced FAD on the 2nd cycle. Let me just check that's it. Yes, all right. So those are is a summary of our products from the Krebs cycle. You only need to know the name of oxoacetate, and also you only need to know, so that's our 4 carbon, and you need to know citrate, which is the 6 carbon, and obviously acetate, which is the 2 carbon. Thankfully, you do not need to know the name of the 5 carbon molecule. Right, so do you remember that I told you for every 1 molecule of glucose, you make 32 molecules of ATP. Now, so far, how many have we made? We've made a net of 2 in glycolysis, none in link, and 2 in the Krebs cycle. So we've only made 4. So 32 minus 4 is 28. So we've got to the end of the Krebs cycle and we have only made 4 molecules of ATP. We still have to make 28 molecules of ATP. And 28 molecules of ATP, in theory, are made in the 4th stage, oxidative phosphorylation. Whilst we're on that subject, actually, let's just write 32 here. Lots of people will be reading around the subject. I don't know if you've got this book. This book here, it says there are 38 molecules of ATP made. This one, 32. This one, 38. This one, 32. All right, very confusing. 32 is the number, all right, that they have now decided is made. 32 molecules of ATP for every glucose molecule. When we come on to showing you how these are calculated, I'll explain why it's 32 now and why they used to think it was 38. All right, so when you read your books, it is confusing, but it's 32 molecules of ATP that I want you to learn for me. All right, so we're now going to go on to the 4th stage, oxidative phosphorylation. I'm going to learn how these 28 are made. Right, I'm going to stop the video now. I'm going to make a fresh one for oxidative phosphorylation. All of this here, nothing new, just a recap of everything that we've done so far up until now. So this is a recap of the first 3 stages of aerobic respiration. All right, okay.